Hello everyone. My name is Sergey and I'm from Percona. And today I'm going to take you to the journey of running MongoDB on Kubernetes with GitOps. My talk will consist of this part. So first one is a brief intro of what we're going to discuss, why it is important, why it is interesting and fun. Then I'm going to go a bit deeper into the details of running MongoDB on Kubernetes, what kind of moving parts are there, why is it not so simple, and why do you need the operator to do that. I'll describe what is Percona distribution for MongoDB operator, what it can do, why it is good to use to deploy the MongoDB on Kubernetes. Then we'll look into GitOps. What is GitOps? Why someone wants to use GitOps? Why it is great to use? And then there will be a very brief demo about what you can do with GitOps and Percona MongoDB operator. That would be fun. Okay, so super quick intro. This is usually how running MongoDB on Kubernetes looks like. So at the bottom, you have infrastructure. This infrastructure can be Amazon, it can be Google Cloud, it can be Azure, it can be some private cloud or OpenStack, it can be bare metal, anything you want, right? A bit higher in the middle, you have Kubernetes layer. Kubernetes comes with hundreds of primitives. It's pods, it's containers, stateful sets, replica sets, role-based access control, everything. You name it, there are lots of them. Keeping all in hand is quite hard. And then the top layer here would be MongoDB, which you run on your Kubernetes cluster. And MongoDB comes with its own complexity. Like there are replica sets with multiple nodes for resiliency. Mongoose, it's a MongoDB router or proxy to route the requests to the needed replica set node in case you use sharding, or it can be one shard node. You have config server where you keep all the metadata for sharded clusters. And here config means that obviously you need to configure your MongoDB cluster so that all replica set nodes connect to each other. Mongoose knows where to route the queries, and so on and so forth. Looking at that, it's quite complicated. It's not easy to manage. It's not easy to deploy. It's not easy to use, right? But on the right here, you might simplify your lives a bit with some tools like GitHub, like Ansible, Terraform, and you automate the work that you do with these tools, right? And then you kind of turn into a juggler, right? Who juggles all these Kubernetes primitives, all these Mongo concepts, all these tools. And if one piece fails, the whole infrastructure goes down, or you lose the backups, or what is worse, you can lose the data, right? So again, MongoDB on Kubernetes is not that easy, and this is how it usually looks like on the higher level, right? If we look a bit deeper into that, this is the MongoDB cluster on Kubernetes. So on the left, you have a service, right? It is Kubernetes object, a service to which you connect. Then your traffic is routed to Mongoose. Mongoose is, again, MongoDB router or proxy, which should route the queries. Mongoose talks to config server replica set. And config server replica set, it's not just a stateless application with a set of pods, it's also stateful because it keeps the state, it keeps the metadata about all the real data that you keep in your MongoDB database and all the collections, right? So Mongoose talks to config server replica set. And then what happens, Mongoose routes to needed replica set node or just a replica set. And replica sets, at the same time, they also consist of multiple nodes or pods in the case of Kubernetes. And these pods, they also have storage. So usually it is a stateful set. And for Mongoose, you can use a deployment because you don't have any storage there. So in Kubernetes world, MongoDB cluster already has lots of containers, already has lots of pods. It's stateful sets, it's deployments, it's a service. But don't forget that on top of that, you also have to configure your MongoDB, right? And manage your MongoDB cluster. Like you want to perform some day 2 operations like backup, scaling, recovery. Like if one node fails, you want to get it back. And doing it all manually is quite a task, right? Even in the outside of Kubernetes world, it's quite difficult. But in Kubernetes, where everything is super ephemeral, there are lots of moving parts. The pods are coming and going, and the nodes can fail anytime. And it's normal in Kubernetes world because Kubernetes manages the containers, and containers are used to be stateless. But in case you have a state, it kind of complicates things, right? Again, why I'm saying that is just to describe the whole complexity of managing MongoDB in Kubernetes, right? And here where operator comes in quite handy. The operator concept, or it was an SDK, was introduced by Red Hat, I think in 2018, and it was the initial prototype release. The idea of the operator is simple. What if the user does not need to manage the Kubernetes primitives and the application in Kubernetes at all? What if the user just talks to Kubernetes API, tells something to it through a specific format, through a simple YAML file, and then Kubernetes takes care of everything, and the operator takes care of everything. So the operator is just a piece of code. And the real value of the operator is that the user gets the service instead of servers, instead of pods, instead of config files. And you see here on the right, there is everything is grayed out here, right? There is a database running there. There are multiple containers, some Kubernetes primitives. The user does not know what is happening there. The user talks to Kubernetes API and says, hey, Kubernetes, or hey, Mr. Operator, I want to have a database with 3 nodes, with 3 proxies, with this number of gigabytes on my storage, with this bucket as configured for my backups, and that's it. And then some magic happens in the background. The user doesn't know what's going on, and what the user gets is just the service object, which the user can use as an endpoint to connect, right? In case of database, it's the MongoDB endpoint to connect to Mongos and to connect to the MongoDB database, right? And then what is the real value, or more value coming from operator, is day 2 operations, because taking the backups of a MongoDB cluster running in Kubernetes is not that simple. It's especially, as you know, the Kubernetes ephemeral nodes can come and go. And operator solves this as well. The user tells, hey, Mr. Operator, just take me the backup and upload it to this bucket. That's it. Or I want point-in-time recovery logs. Just do it for me, please. Or I want monitoring out of the box working, and the operator can provide that. And again, everything is automated. The user does not need to talk to MongoDB itself, does not need to think about Kubernetes primitives. The user just talks to Kubernetes API through a specific format so that it can interact with the operator. And operator is just basically a piece of code which does some magic. Right, and in Percona, I come from Percona. We provide 100% open source solutions for open source databases, including MongoDB. And we have our own operator for MongoDB, which is called Percona distribution for MongoDB operator. The reason is we have our own Percona distribution for MongoDB, which comes with a server, which comes with backup tools, and we just deploy this distribution on Kubernetes through our operator. And our operator supports scaling, like you can horizontally scale your MongoDB cluster with adding more and more shards. You can vertically scale by adding more resources through regular Kubernetes requests and limits. You can horizontally scale your replica sets by adding more nodes. In Kubernetes, it's just adding more pods. You can take backups with our operator. As I mentioned before, we also support point-in-time recovery, which just upload operations logs, op logs to S3 bucket, and then you can easily restore your data, minimizing your recovery time objectives and recovery point objectives. We have monitoring built in. It is automated integration with Percona monitoring management, an award-winning tool for monitoring the databases. But in case you want, for some reason, customize your MongoDB cluster, or you're not happy with our monitoring solution, you can add the sidecar container, which is a concept in Kubernetes, a sidecar container pattern, where you can add a container into the pod, and this container will have access to the storage, networking, and the computational power of the pod, right? So they share all the resources, and you can, for example, add MongoDB exporter if you don't like PMM for some reason, right? This is what Percona distribution for MongoDB is, and we deploy it with our operator on Kubernetes. So let's talk a bit about GitOps, right? I actually stole this picture from another talk by With guys, With Networks. They developed this and created this GitOps approach. And what I really like about this picture is this immutability firewall concept, right? And this is really correct. So on the left here in blue, you have your continuous integration pipelines or flows, whatever you have there. You have development, you test it, you build it, whatever you do. And then you go to GitHub and create a pull request. And this pull request, for sure, is carefully reviewed by the team lead, by security team, by some automation tool, code analysis, you name it, right? And once it is merged, this should somehow be shipped to staging, to production, to other environments. And usually there are a bunch of tools to do that. Like, again, the Jenkins can do it with like a continuous deployment tool, or you can do it with Ansible, with Terraform. Again, there are multiple tools to do that. But the beauty of GitOps that you keep all the operational changes in GitHub, and they are automatically synced to your environments, the environment that you need, like, for example, staging. This is the real beauty, because in this case, really, your GitHub repository acts like immutability firewall, which means the state which you have in GitHub is actually the same as you have in your real environment. And GitOps approach is all about that. Every operation is a pull request. All the differences between the real environment and GitOps are automatically synced, whether you change it on in GitHub or whether you change it on your real environment. These changes must be synced, and the source of truth is always GitHub repository. And obviously, as long as you have a good review process in your organization, all the changes that are made to your application or to your infrastructure on Kubernetes, they can be really easily reviewed, and they are fully auditable. This is the beauty of GitHub. It sort of comes with it, right? And if we recall this first picture that we had, there are lots of moving parts when you want to deploy MongoDB cluster on Kubernetes, right? Hundreds of Kubernetes primitives, MongoDB complexity, lots of tools to maintain it all. And in case if you use operator and GitOps approach, you don't have any of this complexity anymore. What you get is all your changes are done through GitHub. Once they are merged, they are automatically synced to Kubernetes cluster, and MongoDB operator takes care of MongoDB configuration and Kubernetes primitives there completely, right? So this is where simplicity comes from. And instead of being a juggler who thinks of all these moving parts, you just need to think now about GitHub, about how to enhance your development and review processes, your testing, your build pipelines, instead of thinking about the operational burden, because this is all taken care of, right? This is the beauty of GitOps using with operator framework and concept. And for the end user, if we go a bit deeper into the details, for the end user, it looks like the user goes to GitHub, changes the code there, it's carefully reviewed by some other teams, the reviewers, and once it is merged, the GitOps operator, I have Flux here as an example, detects these changes, and as a step number 3, these changes are automatically rolled out somewhere, right? In this case, we have MongoDB in a separate namespace in Kubernetes, and these changes are rolled out. In case of MongoDB, we roll out the MongoDB operator, and we roll out the custom resource, which is basically just the declaration which users applied. It's just, hey, I want to have this number of nodes in my replica set, I want sharding enabled, I want this storage, I want to expose my MongoDB cluster through a load balancer, and so on. So CR, custom resource, is just the YAML file with all the details about MongoDB cluster. And then as a step number 4, Percona operator for MongoDB detects it, some changes maybe, or just detects that there is a new cluster coming in and does all the magic. It provisions the load balancer, it provisions the service, it provisions the storage, everything, right? And again, what the user gets in the end is just the service which just works, right? So the user does not need to think about Kubernetes primitives, about how MongoDB is configured and everything else. And then the user can also have the 2 operations on top of that. Monitoring is already up and running. So all the magic already happened, right? So let's go into the quick demo. I'll give you an example of how this can be done. Let me go full screen and let's start. I will pause. This is a pre-recorded demo so that it goes smoothly. I will pause sometimes the video to explain some of the steps that I'm doing there and what's happening in details, right? So here I already have something in GitHub. I cloned the repository locally, and there you see 2 YAML files. One is called bundle YAML, another one is CR YAML. Bundle YAML is the Percona operator. It is just the deployment with Percona operator pod and with container, and also it creates some role-based access control for the operator itself, and basically this is some service accounts. And CR YAML is custom resource YAML. I will show it to you right now what's in it, right? So this is just the declaration of what I as a user want to deploy and what kind of MongoDB cluster I want. And you see there is a replica set named RS0. It has 3 nodes, right? It has this number of resources, like 300 milli-CPU requests and half of a gig for RAM, right? And here I say, okay, I want sharding enabled. I want config server replica set, have also 3 nodes, and I want Mongo's, it's MongoDB router, to have 3 nodes as well. So everything is listed here. I have fully listed the configuration of my MongoDB cluster in this place, right? Everything is there. It's just a simple CR YAML. I declaratively, I just tell to Kubernetes what is it I really want, okay? So let's move forward. as a next step, what I'm going to do, I'm going to create, oh yeah, so here I'm showing that I have a regular GKE cluster. So no magic, I just provisioned the cluster just now to play with it. I'm going to create a separate namespace for GitOps. And in this namespace, I'm going to deploy Flux. Flux is an operator for GitOps, which monitors GitHub changes and then automatically synchronizes them with Kubernetes. I have installed Flux CDL tool with Snap. I'm on Ubuntu, it's simpler. And now I'm going to install Flux operator into Kubernetes, right? So here you see I have specified my email, the GitHub repository, and the specific GitHub and the specific folder in this repository, which I'm going to monitor through this operator. And I have also specified that I'm going to monitor the master branch. So now the operator was created. The pods are not yet up, I guess. Let's see. Yeah, so they are just studying. I'm watching the whole process. Yeah, now they're up and running. And the only thing I need to do right now is to ensure that Flux can connect to GitHub repository. To do that, I'm going to ask for a key which Flux is going to use to connect to my GitHub repository. This is the key, and I'm going to add this key. I'm going to copy it and add this key to GitHub in the background as a deploy key. You go into the settings of your repository, and there is on the left, you can see deploy keys and just create a new key. By the way, you need the right access, right? Because GitOps operator needs to keep this state. Okay, so let's see. I have already added the key in GitHub, and now I'm showing you that there are no pods in default namespace yet. And let's see the logs of our Flux operator to see if it's doing anything, because there is a reconcile loop in Flux operator which checks every 5 minutes the changes in the GitHub repo. And I can trigger it out. I can trigger it manually, or I can just wait for 5 minutes. But looks like something already happened here. Yeah, so Flux already detected it. The reconcile loop just ran, and as you see, now there are some pods already in GitHub or in my default namespace. And if I'm going to check the process, yeah, I'm going to watch them. So you remember my CR YAML? I created it. I showed it to you. There are 3 nodes for replica set, 3 nodes for config server replica set, and 3 nodes of Mongoose. And now what I expect to happen is that all these pods, all these MongoDB and Kubernetes primitives are going to be automatically created without me doing anything. And here I'm just watching the pods being created. So again, in the end, I should have 3 pods for Mongoose, 3 pods for replica set, and 3 pods for config server replica set, and also 1 pod for Percona distribution for MongoDB operator being created, so that operator can manage my MongoDB cluster. So let's see. The process is ongoing. The Mongoose pods are running. Config pods are almost up and running. So, okay, config 1, crash will back off. It's normal because there are liveness probes, and sometimes there are race conditions. If the pod is not ready yet, the MongoDB cluster is not up, the liveness probe can fail. Okay, let's see, get pods. It's up, it's still not ready. Yeah, this is what I was talking about. The liveness probe will kick in now, and it should go up pretty soon. Okay, crash loop. Yes, running. Okay, I got all the pods up, and also here, if you see, I did kubectl get psmdb. Psmdb is a custom resource object which I created. And you see the status is ready, which means my cluster is up and running. And here is the endpoint, because in my custom resource, I mentioned that I want to expose my Mongo pods through the load balancer. And in Google Cloud, I just created the load balancer object, the load balancer object, and now I have the endpoint. To demonstrate that this is a working service, I will just connect to this endpoint with Mongo client, and we'll see if it works. But first I need to get the password. I'm getting the cluster admin password from a secret, which was also created by Percona operator. So let's see, I will copy the password. I will connect to this endpoint here. It's a load balancer IP and admin. Yep. Okay, it's up and running. Let's see if I can list the shards. Let's see that. Yes, you see, I have one shard, RS0, multiple nodes there. So it's all working, it's all up and running, right? Okay, let's do some changes now. Let's say that I don't want 3 Mongo pods, I want 2 now. So I'm going to change my custom resource YAML. I'm going to now commit the changes with a nice comment, nice and easy. And I'm going to push the changes to my GitHub repo, to the master branch. Okay, and now what should happen is Flux should detect the changes in the GitHub repo. But as I mentioned, Flux has a 5-minute reconcile loop. So I'm going to sync the changes manually so that it's going to be reflected much quicker. Okay, the changes are synchronizing now, and there are in Flux logs. You can see that, okay, I detected the change. I'm going to apply it. Okay, nothing to apply anymore. So everything is applied. And you see, I had 3 Mongo pods, and now I have only 2, right? And again, I didn't do any changes, right? Manually. What I did the change in the CR YAML. I created a commit. I pushed it as a pull request. Obviously, in a production environment, in a big organization, there should be some review process. And once this review passes, the change is merged, and then GitOps operator just catches this change and applies it, right? So I guess this is it for the demo, right? And again, I just want to get back to this picture, right? This is the end state of what end user gets from GitOps and MongoDB operator. Do the change in GitHub, Flux operator, which is GitOps operator, catches this change and then applies it to as a regular Kubernetes primitive, as a regular Kubernetes custom resource. And then Percona MongoDB operator detects this change and applies it. And the database is provisioned. And the user does not know anything what's happening here. What the user cares about is that the change in GitHub was reviewed and merged, and that the user gets this service. So the user just connects to the database, which just works with no complexity, with no visibility of what's going on inside, and with all the day 2 operations, with all the magic in place, right? Okay, I guess it was useful. I hope it was useful for you. And if you have any questions, please contact me on Twitter or through the email. I would be glad to help you. And feel free to contribute your ideas and code to our operator. Thank you very much.